let's talk about integration by parts. So in differentiation, we have had the product rule, which states that if uv, you want to differentiate uv, and this is equal to v and differentiate of du over dx plus u times dv over dx. So now let's say we want to reverse the product rule. So we want to integrate this and get uv. So here we have uv is equal to the integration of v du over dx plus the integration of u dv over dx. Rearranging this equation, we can get the integration of u times dv over dx is equal to uv minus the integration of v times du over dx. So this is the idea behind the integral by parts. Let's see how it can be used. Let's say we want to integrate x and e to the power of x dx. So here, using this, so let's just set u is equal to x and v is equal to e to the power of x. Sorry, dv over dx is equal to e to the power of x. So we have du over dx is 1 and v. So if the differentiate of v is equal to e to the power of x, so v is obviously equal to e to the power of x. So this is v. Now using the same formula, we have this, and this is equal to uv. So u is x times e to the power of x uv minus, here v is e to the power of x and du over dx is 1. So here is e to the power of x dx, and this is equal to x times e to the power of x minus e to the power of x. So this is the integration of x times e to the power of x. Now to do this is no hard thing. You can actually replace e to the power of x with cos of x or ln x, and using the same rule you can get the same answer. The trick here is usually about how you choose u and v. So which u's is to choose and which v is to choose. Now let's take another example and see how can we choose them correctly. Let's say now we integrate x times cos of x dx, and we also set u is equal to x and dv over dx is equal to cos of x. So now we have du over dx is 1 and v is sine of x. Let's see what we get here. So uv, this is equal to u times v, so x times sine of x minus v is sine of x times 1 dx, and this is equal to x minus sine of x times sine of x minus sine of x. The integration of sine of x is minus cos x, so minus here get us plus cos of x. So you should have seen pattern here. So usually for u I choose x, or or in many cases it is the polynomial of x. So here this can be x squared and this can be 2x. So usually you choose u as a polynomial of x, and dv over dx is actually one where it is more complex. So here is a trigonometric function, and the last one is an exponential function. For those cases you should choose dv over dx as cos of x. Let's say if it was 2x, so this is x squared and this will be 2x. So here you have 2x, and so this will be similar to the way it was on the x. So the point is you always choose u to be the polynomial of x, and dv over dx is one of more complex. So that is the trick when you do integration by parts. But the trick has exception. Now why is the trick has exception? Now let's say we have this of x times ln of x dx. Now you would think that we would choose u is equal to x and dv over dx is ln x. So the integral of this is unfortunately very hard to find. So in this case, ln x integral is very hard to find. So this is a special case where when it comes to the natural logarithm, you don't choose that. But this case, this is ln of x and this should be x. And here what you get is the du over dx is 1 over x. And dv over dx, so we get v to be equal to x squared over 2. So here we have uv is about ln of x times x squared over 2 minus v, so x squared over 2 times 1 over x dx. Now this is equal to x over 2. This is equal to x over 2, which when integrate we get x squared over 4. So in this case we can also integrate x squared over 2 minus x squared over 4. So when you integrate that, we get this. So the key is when it comes to integration by parts, if it has ln of x, then the ln of x should be equal to u, and the dv over dx should be equal to x. But when ln of x is e to the power of x or cos of x or any function in that form, then u should be x and dv over dx should be that function. And that is integration by part. And this is the sign of how to choose the correct v and how to choose the correct u.